Hello, welcome back. So in the previous part, we have calculated this first part when angles are placed opposite sides of the gusset plate. Now in the second case, when angles are placed on the same side of the gusset plate, then what will be the strength? Well, there you can see this is the gusset plate and two angles are provided and they are connected along the longer leg. So this leg is basically the longer leg and this leg will be the shorter leg. Okay, so in this case, what will be the strength? So again, the same process we will follow, which means we will find out Rx dash value, Rxy dash value. So Rx is the uh, radius of gyration of the whole assembly along the x-axis, and Ry is the radius of gyration along the y-axis for the whole assembly. So again, you can see the individual, the CG of this upper angle will be approximately here. Okay, so CG of this angle will be here. Similarly, the CG of the whole assembly, like both angle and the gusset, the CG of the whole assembly will be here, and CG of the lower angle, if we look at, it will be in the same line like this one. So like in the previous case, it was the x-axis along which all three CG were in the same line. Now in the second case, we can see that the axis YY, along the axis YY, the CG of the individual angle section and the whole assembly belongs to, it will be along the y-axis. So it means this time Ry dash will be equivalent to the Ry. So Ry is the radius of gyration of the single angle section along the y-axis, while Ry dash will be the radius of gyration of the whole assembly about the y-axis. So because all the CG lies along the y-axis, so that is why both value will be same. While in case of x-axis, you can see the x-axis of the individual angle section, it will be like this one. So this is the x-axis of this upper angle section, and this is the x-axis for the lower angle section, and this is the x-axis for the whole angle, whole assembly. So this capital X is the uh, x-axis for the whole assembly, and this small x will be for the individual axis. So you can see all three axes are not in the same line. So that is why we have to apply, we have to calculate it using the moment of inertia. So first we have to find out moment of inertia for this assembly like we have done in the previous case. But there, this time we are going to do in case of x-axis, while in the previous case we were doing this for the RYY. So in this case, Rxx is to be calculated, while Ry dash can be find out directly from the this symmetry. Okay, so now we will do the same process here. So A dash will be same as we have calculated in the previous case. Ry dash this time will be same, which is 21.8. This we have already find out from the steel table in the starting of this question. So it will be same as for the single angle section. Now in this time we are going to find out Rx dash, which will be Ix dash upon A dash. So this time we are going to find out Ix dash. Ix dash is the moment of inertia of the whole assembly about the x-axis. So this time again we are going to apply the parallel axis theorem, and according to parallel axis theorem, it will be 2, because there are two angle section and they are at the same distance. Again I'm making the same, so this distance and this distance both are same. Okay, so that is why I am multiplying this by 2. So Ix is the moment of inertia of individual angle section. So this we have find out already from the steel table. Similarly, the Cx value can also be find out from the steel table. And A, this time you can see that I have not like in the previous case we were multiplying like Cy plus Tg by 2. But this time I am not doing this. Why? Because you can see here there is no gusset plate in between these two legs. So that is why this time I have written Cx directly. Okay, so this we have to take care of. So putting all the values in the formula, we find out Ix dash as 519.98 into 10 raised to power 4. So all the value we have find. Now we will find out Rx dash value using the relation, this one, and 44.11 is the radius of gyration along the x axis of the whole assembly. So Ryy was 21 and Rx is 44. So R minimum in this case will be 21.8. So that is our R minimum. So we find the R minimum. Now we will find out the effective length, because ultimately we need to find out the lambda. So lambda, for the lambda, we will find out effective length. So effective length will be same as we have calculated in the previous case, A. So it will be 0.85 times of L from the same clause. So it will be same 0.85 times of L, and L value is already given in the question, which is 4 meter. So 0.85 into 4, it is 3.4 meter. Okay. Sorry. So now slenderness ratio will be calculated as 155.96. So again, you can see this ratio is less than 180. So again, it is safe, because this reference is from the table 3. So it is safe. So now we will find out the FCD value. So FCD value, for that, first we need to find out the buckling class. So we already know that buckling class for our section will be C, and using Fy as 250, lambda as 108, and buckling class as C. So using this table, we will find out the value of FCD. So you can refer to that table. I have already explained this process. So this is the process of finding FCD value. So in this case, FCD value is very low, which is 55.68, and strength of member in this case would be 55 into the effective area of cross section, which is the total area of cross section of both the angle section. So in this case, you can see the strength of member is very low, which is 148 only. So now you can see that why it is low, because when we provide angle on the same side, the eccentricity is more, and that is why the strength is low. So similarly, if we provide angle section alternatively on the opposite side, one on one side, other one is on the other side. So in that case, the eccentricity can be reduced and the strength of member will be large. So when the strength of member, strength of angles, when they are provided opposite sides of the gusset plate, the strength was 258. Well, when we provide them on the same side, the strength drastically reduced, and it is remained like this, 148.78. So with this, we can conclude that angle should be provided on opposite sides of the gusset plate or any section, so that we can utilize it more effectively. So that was the solution for this example 4. Thank you.